This lesson is on polynomial end behavior. The end behavior of a polynomial is when you're looking at its graph and you're seeing what it does on the ends, meaning the extreme left and the extreme right. And there are four outcomes of how this could look. If you think of the ends as two arms, the two arms could both be facing up, the two arms could both be facing down, or you could have one arm up and one arm down. I'm going to summarize these outcomes in the chart on the upper right. If the polynomial is classified as odd positive, it's going to look like this. One arm opening up to the right and one arm opening down to the left. Again, because this is called end behavior, we're focusing just on what's happening on the right and the left, and we don't care so much right now about what's happening in the middle. So I'll just denote the middle area by these three dots. Another possibility is that it's odd negative, which would be one arm opening up to the left and the other arm opening down to the right. And again, the middle is unknown. A third classification would be even positive. This would be if both arms are opening up. And finally, we have even negative, which would be both arms opening down. So the question that you're probably wondering is, how do you know which of these four classifications you have? Is it odd positive, odd negative, even positive, or even negative? And this is going to be answered by looking at what's called the dominant term of the polynomial. This is the term of highest degree. It's the term that has the largest exponent, or the highest power. Now, once you've determined what that is, you'll be able to make the appropriate classification. So looking at the upper left corner of the screen right now, hypothetically, let's suppose that this is our dominant term. This is our term of highest degree. Well, to determine whether if it's positive or negative, we're going to look at the coefficient out in front, a. So this guy will determine whether we have a positive or negative situation. The exponent will determine whether we have an odd or even situation. So we've got quite a few things to think about, and I'm going to start by actually looking at example 3 to determine the end behavior of this polynomial. And I'm starting with example 3 because it's a little bit easier when it's in expanded form. So I'm going to skip around a little bit, which is strange, but I think it's going to be better overall for you. So step 1 in looking at number 3, identify the dominant term, the term of highest degree. So as I scan through these four terms, I realize that the first term is the dominant term. Now, I see that the coefficient is negative because of this negative 8 here, but I also see that the exponent, 3, is odd. So this is odd negative. And what that means is that if I were drawing this polynomial or sketching this polynomial, it's going to have a certain appearance on the ends called the end behavior. And that's going to look like one arm up and one arm down. The arm that's up is to the left, and the arm that's down is to the right. So at this moment in time, I'm not so concerned with what's going on in the middle of the graph. It's what's going on the ends, called the end behavior. Okay, moving to the example 4. This is another polynomial in expanded form. I'm going to scan through the terms and identify what is the dominant term. And I see here it's actually the second term. Take a moment and see if you can establish what its end behavior is. Is the coefficient positive or negative? Is the exponent odd or even? Well, as some of you may have guessed, this one is odd positive. And the reason it's odd positive is because the coefficient in front is positive. The exponent is 9, which is also an odd number. So this is going to be odd positive. Take a moment and see if you can sketch what the end behavior is going to look like before I do it myself. Okay, so it's one arm opening up to the right and one arm opening down to the left. Okay, so the first two examples that I showed you were polynomials that were in expanded form. It's not always going to be given to you that way. Sometimes they're going to be giving you the polynomial in factored form. This is a little bit more challenging, but it's certainly not impossible. Okay, so if I want to figure out the end behavior of example number 1, what I need to do is look at each individual factor that contains an x and see what kind of contribution each gives. So when I look at this first factor, x plus 3, if I treat that as its own little polynomial, its dominant term is x. So out of this whole first factor here, its dominant term is x, because it's x to the first. When I look at the second polynomial, or the second factor I should say, and I treat this as its own polynomial, I can imagine squaring this out. X minus 4 times x minus 4, that would give me a dominant term of x squared. Now moving to the third factor and imagining multiplying it by itself 3 times, x minus 1 times x minus 1 times x minus 1, the dominant term of that resulting polynomial would be x cubed. Now these are factors, and by definition factors are things that you multiply together. So if we multiply these together, we would retain the base of x, and we would add the exponents. 1 plus 2 is 3, and 3 plus 3 is 6. Now, the 1/2 in front tells us that the coefficient is going to be positive because it's positive 1/2, but it could be 3/4, it could be 7, it could be 20. Just the fact that it's positive is all we care about, so I'm not even going to bother to write the 1/2. So this is going to be our dominant term if we were to FOIL all this out. So let's take a moment and consider what's its end behavior. Looking out in front, we've got this coefficient that's positive. It's specifically positive 1/2, but it doesn't matter. And we've got this exponent of 6. So take a moment and look at our little option chart here on the upper right and think about which option it is. If you guessed even positive, then you're correct. The coefficient in front is positive and the exponent is even. So it's even positive. Now take a moment and try to sketch what the end behavior is going to look like. If you guessed both arms facing up, then you're correct. Okay, and finally looking at the last one, example 2, we're going to do the same thing. This is another example of a polynomial in factored form, a little bit more challenging than an expanded form, and my strategy is to look at each factor separately and ask what is the dominant term of that individual factor. So when we look at our first factor, take a moment and think about what the dominant term of just that factor is. If you guessed x, then you're correct. Now, in the second factor, the dominant term is x squared. That was a terrible brace, by the way. Now, the third factor, here we go, let's try to redeem ourselves. Oh yeah, that is ridiculous, amazing. The dominant term is x, but it's being raised to the power of 5. So just imagine x plus 1 times x plus 1 times x plus 1 times x plus 1 times x plus 1. If you FOIL that out, your first term would be x to the 5th. Now bear in mind, all of this is preceded by a negative, so that's going to be an important factor here. Well, no pun intended. It's not really a factor, but, well, I guess it is. It's a factor of -1. So multiplying all this out and including the negative, we get negative x to the 1 plus 2 is 3, 3 plus 5 is 8. Negative x to the 8th. So think about just the words of the end behavior. Odd or even, positive or negative. Write down what you think it is before I do. If you guessed even negative, then you're correct. Now take a moment and draw what you think is going to be the end behavior. If you guessed 2 arms both facing down, then you're correct. Great, so this lesson was on end behavior, and this is just one piece of a bigger puzzle that you're going to use to come up with an overall sketch when you have to sketch polynomial functions from beginning to end. This was just one piece establishing the end behavior.